Okay, here's the video to show you the answers and explain the concepts. This is the answers for period 1. Here are the answers for period 2. And I'll explain the concept for period 4. The graphs were slightly different, so their functions were slightly different. So looking at the graph and the questions, if you look at the points I put on there for you, you can find out the square 4 times 4 has got to be 16, 4 and 4. So 16 divided by 4 is going to make 4. So putting in the points would help you figure out the equation. Just like all the other ones we did in class, the domain and the range are both 0 to infinity because it's a real life problem. It always lives in quadrant 1. But we need to put that in some context. So in this case, I changed the verbiage up here to make it make a little more sense for the students. On the x-axis, the domain is in miles per hour. The range is in time or hours. Okay, that means the end behavior, as this goes out towards 0, is going to be nothing on the left, 0 on the right. The context is, and it makes sense, as the speed gets faster, the time required decreases. That makes sense. Same thing for the limit as we approach 0 from the right-hand side. That's what this says right here. As the speed approaches 0, we're always talking about the independent variable, speed approaches 0, the time goes towards infinity. That makes sense. The slower you go, the longer it takes. This graph up here is never increasing. It's always decreasing from left to right. So our decreasing interval is the same as domain and range, and it's going to be the same rationale and context as the end behavior is. And this is also characteristic of a positive a value for a rational equation on the right side of the vertical asymptote. So the vertical asymptote is 0 on the right side. This is what a rational equation does because it makes sense. As you plug in larger and larger numbers here, this number is going to get smaller and smaller and smaller. So to answer our specific questions, going from 6 a.m. to 4 p.m., that's 10 hours. Time is on the y-axis. Where's 10? It's about right there. So the x value is about 1.6 estimated. So I need to go 1.6 miles per hour. Again, you got to put it in context and pick off a point off the graph. So for number 2, 7 to 11 is 4 hours. Where's 4 hours in time? It's right there. That means I need to go 4 miles per hour. And the third one was a trick question. What speed should someone row to minimize? Is there a minimum of this function? No, it approaches 0, the end behavior, but it's never going to get there. You're never going to minimize this function. So that's a concept question, kind of a trick thing. Wanted to see if the students got it. All right, that's it.